Hello. A very good morning and welcome to all on this second day of International Conference on Green Energy 2023. On behalf of AISSMS College of Engineering, I wholeheartedly welcome speaker for today's session, Dr. K.C. Mohite sir, Principal, Shirur Shikshan Prasarak Mandals, Chandmal Tarachand Bora College, Shirur. I also welcome Dr. Bormane sir, our Principal. First of all, I would like to request Bormane sir to please felicitate our guest for today. Before moving forward, we will first have the unveiling of the souvenir of the International Green Conference, that is iCoach 2023. I would like to request sir to please click the link of the same.
लोड व्हायला वेळ लागतो मे बी.
I would now like to request our principal, Dr. D.S. Bormane sir, to please say a few words.
Good morning, one and all. Good morning. Yeah, thank you. I personally, on behalf of AISSMS College of Engineering, welcome Dr. K.C. Mohite sir for today's keynote speaker. He is working in this field, energy field especially, since many years. Just he saw our leaflet and he called me, sir, you are conducting very good activity. I am interested to be part of this activity. That is the spirit of Mohite sir. I will not take much time, but I be here to just welcome him and appreciate Mr. Mavle and his entire team for coordinating and conducting this conference on green energy. And I'll appreciate all the students of our college. Sir, for your information, the Swaraj Energy Foundation of IIT Mumbai, that Professor Suryanshi, he has taken initiative and launched energy awareness training program. And in our college, around 4,000 student, faculty and all are enrolled, and almost 2,000 completed training course. And that is a great initiative. Of course, key role of this initiative is Mr. Mavle. So a big hand for the clap for the Mavle sir. Because nowadays this awareness about the energy is very, very important. One should care about the energy which is, and definitely are going to get more and more insight. Sir, we are going to focus on the various aspect. So, best luck, best wishes, and thank you.
Thank you, sir. It's my privilege to introduce you all to our guest speaker for today, Dr. K.C. Mohite, sir. Dr. Mohite is working in the field of renewable energy sources and material science since last 28 years. He completed his master in physics in collaboration with Tata Institute of Fundamental Research, Mumbai, and PhD in physics at School of Energy Studies, SP Pune University, India. He was instrumental in developing first offshore campus and shouldered the responsibility as a founder director of University of Pune branch campus at Ras Al Khaimah, UAE. He has also shouldered the responsibility as a dean, science faculty during the period of 2011 to 15 and was also a member of academic council and has been a chairman of BOS in physics. Sir has published more than 100 research papers in reputed international journals and conference proceedings. He has to his credit 5 reference books and 6 textbooks and more than 150 articles in newspapers and magazines. He is a recipient of C.V. Raman Best Teacher Award in Physics by IPA, Baba Atomic Research Center, Mumbai, and 2 research awards by SPIE Institute and ICM CTF organization from USA. He is also honored with the Excellence Education National Award by AICTE, MNRE and MSME Government of India in 2014 for contribution in bridging the gap between academia, R&D and industry. I would like to request Sir to please address the audience.
A very good morning, principal of the college and my friend Professor Bormane, the convener of this international event, Professor Maule, all his team and dear student friends. This is indeed a great pleasure to be a part of this international event, and that too on green energy. Since energy is heart of myself, and so wherever energy word I see, so always I have a different kind of affection of this energy. Since with this word only I could travel whole world, starting from USA, France, Germany and many countries, and money from not from my pocket, from USA or France, or that government had taken care of it. So what I want to say is energy has a tremendous importance, and on this occasion I would like to congratulate basically Professor Bormane sir and their team. In fact, to have a SESI, the Office for Western Region, in your college, it's a great honor, since Solar Energy Society of India, since I am working in this field since last almost 35 years. 1986, in fact, I started working, 86 to 88, and then later on, earlier in energy, there was a DNES at central government, like Department of Non-Conventional Energy Sources. Later on, it became MNES, means Ministry of New Non-Conventional Energy Sources, and later on, now it is MNRE, Ministry of New and Renewable Energy Sources. So there are a lot of changes which are happening over here, and fortunately, our central government has taken care of this energy aspect, and that is one of the reasons that many areas now renewable factor is coming up, but still we have a tremendous scope. I always say that the E itself is a very important, like E is for environment, A is for economy. As we know that the country which has a good economical aspects, then definitely there will be more and more progress. And economy is there, environment is there, education. good quality education, imparting good quality education is equally important. And then other factors, energy itself is one of the thing. And fifth and very important for you all young students is employment. Since unless and until we have employment, we will not be able to get progress in any kind of field. So the 5 E's are very important, and on this line, if you look at these E's, then energy plays a very important role. Like economy, as you all know, our GDP, as you know, that it depends on energy. What kind of energy, like oil, gas, we all know that we are not good. We don't have resources, and therefore we do import from other countries. And that is one of the reasons that we are not able to, be independent in energy aspect. I know that there are 2 countries, France and Germany. France, as on today, is using more than 70% nuclear source as the main energy. And Germany, even though they are in Europe, Germany is in Europe, still they are using a solar energy. But in spite of having a good resources, natural resources we have, but still we are not able to utilize our natural resources, whether it is solar energy or wind or biomass or different kind of other renewable sources. We are not able to tap it and focus it on this particular line. So there are many opportunities. What I wanted to say is that there are tremendous opportunities in this field. So I would like to just highlight some of the slides that where we are going and what exactly we should do. So before that, I always say that as far as the overall education is considered at international level, we see that there are US and UK. If you look at the first 50 topmost universities in the world, you will see that they are either from US or UK. Around 35 to 37 universities or institutions are from US and UK. And then the remainings are from Japan, Germany, Europe, or some Asian countries. And if you look at the research point of view, where we are, so fortunately we are doing better. The number of papers, patent filing and all these things. But still there is there are many controversies that whatever the research we are doing over here, whether it is a quality research or not, and whether it is replicable or not, repetitive or not. Like we do publish a paper, but whether the same situation, same parameters if you use, whether I will be able to get the same result or not. I think that is again it's not an easy task to find it. And therefore these are some of the issues where we need to focus and come out of it. So I would like to show some of the slides, please. Yeah. I will not go into the details of all, but these are some of the issues as we all know. Food security is one of the challenge in front of climate change, energy security, water security, natural resource depletion, growth, employment, natural resource sustainability, and so on. So very much is required. Innovations in these fields are really required. Agriculture, energy needs, medicine, industry, transportation, aeroplanes, computers, space, environment protection, living system, and so on. What I always talk about the innovation is like whatever the new idea you have, you can file a patent, for example. That can be invention, but it is not innovation. So for innovation, you will have to work very hard. It's not direct step. So that fresh idea will have to get invention, and then you can go for innovation. But directly going for a new idea and innovation is not possible. So what is desirable to users, what is possible with technology, and what is viable in the marketplace. These are very important aspects of any kind of innovation. So these are the greatest innovators of all time, Thomas Edison and his people. What Einstein had said that we cannot solve our problems with the same thinking we used when we created them. The way we have created the problem, same way cannot be applied to solve the problem. So we'll have to apply different minds, and many people are required. Creating a problem may not require many people. One person is also enough. But solving problems will definitely require many, many people, many aspects, many sectors, many areas are required. So this is the innovation. As we know, we are in the sixth innovation. So first wave, second wave, mechanization was there, electricity was there, petrochemicals, IT, BT. In 1990s, we always talk about IT and BT, information technology and biotechnology. But now that has gone, and now we all are, in the sustainable development now. Each and everyone, whether you will be a mechanical engineer or electrical engineer, IT or medical doctor or physics, chemistry, whoever you are, each and everyone will have to work in a sustainable development, sustainability. And I think on that particular background, this today's conference is very important. It's all green energy. So green energy is the only aspect which is going to solve many, many problems. So Human Development Index I always talk about, since almost all the around 200 countries, and we see that where we are. Human Development Index is the index which gives the idea that how is the overall development of that nation. As far as the education is concerned, as far as the employability is concerned, as far as the girls' education is considered, as far as the our elders, how we treat them, what kind of facilities we provide them, and so on. Infrastructure, many, many aspects are covered in this Human Development Index. Not only that, the happiness index is also there. Whether our people are happy or not, our students are happy or not. So all these aspects are considered, and unfortunately, we are not in first 10, not in first 50, not in first 100. Our number is 132 to 35. Since last decade, I am observing this index, and we are in the range of 130 to 135, 38 also sometime, but we are not at all in a good position. It means that we have tremendous scope. So whenever there are difficulties, whenever there are barriers, it means that we should see it as opportunity. So it means that we have opportunity to do something, and that is the reason I think we should work. So these are the top 10 countries: Switzerland, Norway, Hong Kong, Australia, then Sweden, Ireland, Germany, Netherlands, and all this. And we are, as you can see, we are not at all good, but the Sri Lanka, China, Bhutan, they are also better than us, it means. So it seems that we have a tremendous scope. Otherwise, we feel that in the city like Pune and Mumbai, Delhi, Bangalore, we see that their infrastructure is good, this is good, that is good, but still, if we see that there is a tremendous scope, and therefore we youngsters, you all youngsters, should find some problem so that you can work on it and you will get whatever you want in your life. Okay, it will be a great future for you. So this is what global innovation which I was talking about. Whether the research, any doubts please? Any doubts please, otherwise I can stop, you can ask me so that we'll have interaction. काही डाउट्स असतील तर विचारलं तरी चालेल. मराठी येतं सर्वांना? सर्वांना? तुम्हाला येतं? हात नाही वर केला म्हणून म्हटलं. ओके, मला वाटलं काही शंका असेल तर विचारा, आवडत नसेल तसंही सांगा, मी थांबतो म्हणजे आपल्याला जाता येईल. ओके, सो मला वाटतं की थोडं अजून जरा चुळबुळ चालू आहे, ती जरा आपण थांबूया थोडा वेळ, जास्त वेळ घेणार नाही मी, अर्धा तास फक्त. आणि इफ यू वॉन्ट यू कॅन वी कॅन interact definitely. So GII, Global Innovation Index. So whatever the research is happening in my university or in my state or in nation, whether that research is going to help in some aspect, some element, some society, okay, some area, whether or not, I think that index is the Global Innovation Index, and it means that our research should be converted into innovation. So there again, we are not doing better, as you can see. These are the top 10 countries: Switzerland, United States, Sweden, United Kingdoms, Netherlands, Republic of Korea, Singapore, Germany, Finland, Denmark. The bracketed numbers are the previous ranking, last year's ranking. Like Switzerland has maintained, the United States, they are now 2, earlier last year they were 3, like that. Sweden now 3, earlier they were 2nd, and so on. But Fortunately, India is, is a progressing. See, you can see that in 2015 it was 81 and now it is 40. So it means that we are improving, but still there is a tremendous scope. We are not in first 10. We are 40 number. This year, these are very recent figures. So of course we have a scope and we are doing better, but still there is a tremendous scope. So as far as the renewable energy sector is concerned, globally is fourth position in overall renewable energy sector, 42% cumulative installed capacity from non-fossil fuel source, 50% targeted till 2030. Renewable power generation increased 1.5 times from 196 BU to 291 BU since 2014. Solar power installed capacity increased 25 times from to almost since 2014. Wind capacity increased 2 times from 21 gigawatt to 42.6 gigawatt since 2014. These are recent figures which I am talking about. About $78 billion investment since 2014. Third highest renewable energy capacity addition of 63 gigawatt in last 5 years. Innovative policy interventions such as ISTS, waiver, RPO and some other things are there. So green open access rules are introduced. So these are some of the highlights of what India is doing in renewable energy sector. If you talk about solar energy, we have tremendous potential. In 1 second, if our sun produces the enough energy to meet the current needs of the entire earth for so many years. If you are able to catch solar energy for just 1 second, then infinite time, in fact, you can fulfill your needs of energy. But it is not so easy task. Capturing or taking all the energy in your control is not easy task. So solar energy, as we all know, that how much radiation is coming and absorption, reflection, the diffraction is there. There are many things are there, and still, of course, whatever the source we have, still that is more than sufficient as per our needs are concerned. So there are number of economical benefits. Eliminates or reduces the amount of electricity purchased from utility providers, affordable and renewable energy source, quick turnaround for system owners, incentives offered by state and central government, that is also good sign, and generates electricity at the time we need it the most. So in the daytime, as we know that we need more and more energy, electricity, and fortunately in daytime we have a good source of energy from sun. So this is the picture where how much is the solar energy, like intensity of solar energy radiations. As you can see, Rajasthan mainly has the highest intensity, and other areas are middle or something like that. So again we have as you can see, the potential of solar energy. So sun is the soul, as you can see, yellowish one, and the other things, tidal, how much it is, geothermal, hydro, biomass, and other factors, as you can see. So sun is a tremendous source of energy, and therefore we should try to utilize this source of energy. So this is the wavelength against intensity, or what we can say, the energy against wavelength. As you can see that the visible region has a maximum input, maximum radiations we get in the visible region. That is also good sign, so that you will be able to convert it into useful form. Why at all we should go for it? Solar energy is abundant. It is a free source of energy. Solar energy is cost effective, and it is a clean source of energy. And more of the addition to that, it's a democratic source of energy. It is not concentrated only in Mumbai or Pune. Okay, it is everywhere, isn't it? In fact, if you go away from cities, you will get more and more energy. So it means it is a democratic in a true sense, and so therefore we should try to get maximum out of it. So how we can really convert into useful form, that is actually issue. And there actually we have a number of opportunities. Research opportunities are there, job opportunities are there, invention, innovation, so many opportunities are there in this particular field. I don't know whether you are able to see it or not, but this is the picture, like it's NREL, it's a very recent efficiency graph, which gives the idea that how much is the efficiency of the different materials. There are, this is the photovoltaics, solar cells. I hope you have studied this. Solar cells, yes, PN junction, you know, whenever the solar radiations falls on it, then we have EHP, electron and hole creation. Then one side you will get more and more positive charges, other side you will get negative charges, and ultimately you will get a potential across it. You know, that's a photovoltaic principle. So using this particular, whether it is a single junction, two junction, multi-junction, that is one thing. Secondly, which kind of materials you are using, that is also one thing. Thirdly, whether it is the same material but a thin film you are using. Earlier it was like still, in fact, we are using silicon as a main source of energy, main source, main material, in fact, for making solar cells. And that too, single crystallized silicon, we get a better efficiency. But now multi-crystalline solar cells are coming up, and now three-dimensional 3D solar cells are coming up. Then now flexible kind of solar cells are coming up. There are many things which are coming up, and ultimately what scientists or researchers are working is to reduce the cost and to get the more and more efficiency, and let it be portable. How it can be portable? So I think on this line, all the researchers all over the world, they are working in this particular field. So there are many opportunities in this field. You can see that almost 47%, 48% efficiency is possible. So earlier, see what happens basically is that if you look at this spectrum, you see that the visible part, where if you have only one junction, then only small part of energy is used for converting into electricity. But if you use two junctions, then maybe your more spectrum will be utilized. Otherwise, if it is a single junction, maximum what you can utilize is only 45% of the total spectrum. And in that 45, again efficiency will be 50% or something like that. It means that your efficiency will come out to be 22%. There's a basic question, why the solar cells are not giving a good efficiency? That is one of the reasons. Since you are not using total spectrum, you are using a very small part of the solar spectrum. That is the main reason why efficiency of solar cell is less. And therefore the multi-junction, two junction, three junction, the multi-junctions are used so that other part also can be used, other part of the spectrum can be used, and you will get a more and more efficiency. So these are the first generation PV cells, single crystalline silicon, then multi-junction, different band gap materials are being used. Then second generation PV cell, thin film silicon, amorphous silicon, cadmium telluride is a very important candidate in this field. Then the CIGS is there, CDT is there, copper indium diselenide, copper indium sulfide. These are some of the very important materials for thin film material solar cells. See, when we talk about a solar cell, it's a general solar cell, silicon solar cell. Its thickness will be around 300 microns. But if you go for thin film, it will be only 1 micron. Any question? So it means that you are going to reduce the material cost, the total amount of material you are going to reduce. So ultimately, your cost will be less, and with a very small material, it will be flexible also. You can even paint it, and you can get a conversion from solar to electricity. So cost of making solar power system. So it is not that only silicon is playing a main role. In fact, there are some other factors as well. PV modules, cable, DC-AC, interconnection cost is there. Other factors are also involved, and therefore the total cost goes high. That is one of the reasons. It is not only that the silicon solar cell. There are some other parameters due to which, other components, due to which the cost of this whole system goes high. So small scale installations are now becoming more popular. Choosing solar for the driver's seats, sustainability and environmental footprints, solar increasing leadership from private sector looking for green procurement, solar in emerging market, so much untapped potential, tremendous potential is there, and we need to tap it. So there are so many opportunities. thousands and lakhs of opportunities are there. Whether you are in solar energy, bioenergy, hydropower, wind power, geothermal, there are so number of opportunities are there. So basically engineering students should try to tap these opportunities. There are so many opportunities. So you should grab these opportunities. So these are the very recent figures, how much renewable component is there. Non-renewable, for example, in 2010, it was 88.9%, then it went to 11.1, then 85.3, then 14.7, 15.5, and so on. So it means that the renewable energy factor is increasing, but not like what we are expecting still. So that is, I think, a main problem. So again, as you can see again, in vehicles, basically transports, 97.4 non-renewable was there, only 2.6. Now it is increased 4.1, but still there is a tremendous, again, now EVs are coming up. I think that will be definitely useful to use more and more renewables in the transportation. So there are various sectors that electrification, for example, earlier it was 6.7, 7.3, 32%, food and tobacco, pulp and paper industries, mining 14%. So renewables are definitely coming up, but still there is a tremendous scope, as we can see over here. Share of renewables in agriculture. In agriculture, it was 10.2% in 2010, then 2019, 15, then 15.4. So again it is increasing, but still again there is a scope for increase. So these are also some of in the building sector, for example, buildings 33%, industry 33%, and see these are some of the figures, in fact, to know that how much part of renewable energy is utilized in various sectors. So it's electricity and in renewable, as you can see again, earlier it was like 5.4, 6.1, 7.9, and so on. So these are some of the largest solar plants in the world. Solar plants means I am talking about photothermal. See, photovoltaic is there, photothermal is there, then wind is there, biomass is there, then geothermal, and so many renewable energy sectors are there. So in Gujarat itself, in Rajasthan itself, this is one of the biggest plant in the world. It's a Badla solar park. It is installed 2,245 megawatt, means, so it's the biggest plant. Then the second one is in China, then again in India is there, Karnataka, then Egypt is there, and then China is there. So China is in fact leading in the many sectors, but still India is also coming up last 5 years or decades. In fact, India has taken initiatives. There are some of the figures, plots, pictures of this our plant, which has been installed now. Some of the pictures from different areas, from China, India, Egypt, and so on. This is a different kind of plant. In fact, it is the largest concentrated solar thermal power plant. So concentrating type of technology is coming up, not only in photothermal but photovoltaic also. And concentrated solar energy you can get in thousands of temperatures. You can get 1,000, 2,000 degrees centigrade as well. The first scientist who uses solar concentrator, have you heard about him? No? Have you heard about Archimedes? He is famous for one thing. What is it? Yes? Eureka, Eureka, right? Archimedes was famous for Eureka, बरोबर ना? आंघोळ करताना एकदम बाहेर पळून गेला. माहिती आहे का? मी सांगत बसणार नाही, पण माहिती करून घ्या. ओके? So actually Archimedes was asked by his king, the enemies are coming up through sea, and how to how to protect them. Okay, how to kill them, how to use all our weapons. So he was asked so many years ago, 1,000 or 2,000, more than 2,000 years. So he was asked to do this job. Otherwise finished. That was the era, you know. A scientist has to work as per what King was saying. So he tried his level best. आणि सर्व बीचवरती त्यांनी कॉन्सन्ट्रेटर लावले आणि ट्राय टू फोकस इट ऑन द ऑल द शीट्स. जे काही जहाजं येत होती त्या जहाजांवरती फोकस केले आणि ही बर्न दॅट ऑल शीट्स. सो दॅट वॉज द फर्स्ट use of these concentrators in a big way rather. So there are many applications of this one, and you can see the tremendous energy you can generate out of it. You can convert it, the solar energy, through photothermal into electricity directly. You can generate heat also, and from that you can generate electricity also. So these are some of the challenges, of course. Even though it's a good, you see that it's a very nice field, but still there are a number of challenges as well. Although several renewable heat technologies for low to medium temperature processes are on the market, fossil fuel based heating technologies generally remain more cost effective, hindering the adoption of renewable solutions. Renewable technologies for decarbonizing high temperature industrial process remain limited, and further technological development is very much needed. Many industry sectors are capital intensive with long lived capital assets. Switching to renewable technology is expensive due to the long lifetime of industrial equipment and plants. Tailoring policy to the needs and characteristics of different industries is challenging, as the heterogeneity among subsectors, including in energy use and intensity, impairs having comprehensive policy. So policies and there are technological limitations, and therefore these are some of the challenges. But there are a number of opportunities as well, like the potential for using industrial heat pumps in low temperature heat applications is high. This has the advantage of both reducing cost through energy efficiency and providing low carbon energy. Renewable hydrogen can be used in many energy intensive industries where it is challenging to 100% renewable technologies. Small and medium sized business have significant untapped potential for uptake of renewables, while simultaneously increasing their competitiveness through cost savings and improved sustainability practices. Investment in decarbonized steel, which may include the use of renewables, are driven by the wish to capture opportunities in incipient green steel markets and to avoid standard assets in anticipation of more stringent climate policies. So there are a number of opportunities in almost various number of sectors, and we should try to tap this. So these are some of the upcomings in renewable energy sector. Impact of top 10 renewable energy trends and innovations in 2023. Very recently, we found that advanced photovoltaics. What is going to happen in photovoltaics in the coming years? Then artificial intelligence and big data, how it will be used in renewable sector. Then distributed energy storage systems. Storage is one of the big issue. Hydropower, wind energy, bioenergy, green hydrogen, and so on. These are the number of researchers and startups are coming up in this field. So advanced photovoltaics, then it has been luminescent solar concentrators are coming up to overcome the efficiency and some other barriers. These type of concentrators, solar concentrators are coming up. Then Norwegian Crystal makes low carbon monocrystalline silicon ingots. The very recent figures, these are the startups which has been already started, and they are becoming a big companies now. So if you are really interested, there are many opportunities in these startups as well, or otherwise you can start your own. How artificial intelligence and big data is going to help in energy parameter analysis and facilities in different intelligent energy trading. It has been really used. For example, in India itself, as you know that the east and west, it's around 1 hour is a difference. So the peak hours, maximum you use electricity. So that can be trading can be done, and for that reason artificial intelligence and big data can be used. So wherever you will find that there is a more load, then definitely the energy will be transferred to that area, and otherwise in other sectors, other regions. Similarly, distributed energy storage systems. See, solar energy, for example, we have batteries coming up. Now, of course, lithium we are using. Yesterday, Dr. B.B. Colley talked about this. I'm sure that he talked on this line. And of course, new batteries are coming up. Maximum capacity is required and durability is very important. Otherwise, there are some incidences where there is a blast in the vehicle or something like that. I think that care need to be taken, and therefore again, research and innovations are really required in this field. So green Y energy offers mechanical energy storage, number of storages. In fact, these are some of the things where we are really see that some new things should come up. Thermal produces thermal energy storage materials. There also we have a tremendous scope, different materials. Hydropower, yesterday we had a lecture, of course. So it's also dividing from, of course, moving water. Unlike solar and wind, hydro energy is predictable and more reliable, besides different problems, but still there is a scope. Green energy development, then sea-based providers, modular wave energy converters are also required. I think some students have some problem, or yes? Wind energy, there are again vertical axis, horizontal axis, and we see that there are a number of plants which are available. तुम्ही कुठला wind energy plant पाहिला का? Yes? चाळकेवाडी जाऊन आलात? चाळकेवाडीला जाऊन आलात का? मग गेलात का? हे प्रत्यक्षात पाहिलं का तिथे? लांबून पाहिला का जवळून जाऊन पाहिला? लांबून पाहिला, जवळून पण जाऊन पहा, मग तुम्हाला ऍक्च्युअली अनुभव येईल की विंड एनर्जी दुरून कशी दिसते आणि जवळून काय दिसते. सो ह्यूज प्लांट्स, खूप खूप मोठे आहेत, आणि देअर वी रिक्वायर ट्रिमेंडस मॅन पॉवर, स्किल्ड मॅन पॉवर. सो ऑल द इंजिनियर्स अँड ऑपरेटर्स आर रिक्वायर्ड. देर आर मेनी प्लांट्स, 1 मेगावॅट गिगावॅट पर्यंत पण मोठे मोठे प्लांट्स आहेत. ओके, चाळकेवाडी इज अ बिग प्रोजेक्ट, but still there are many projects around. In fact, if you go Ahmednagar, there also you will find that the Parner near जाताना तुम्ही डाव्या बाजूला पाहिलं तर तुम्हाला विंड एनर्जी प्लांट दिसतील. one of my student is a general manager over there. सुझलॉन कंपनी आहे किंवा अनेक कंपन्यांमध्ये असे आमचे विद्यार्थी आहेत. तर निश्चित तुम्हाला कधी लागलं तर त्याची मदत मिळू शकेल. हेलिक्वाइड एनहान्सेस विंड ब्लेड क्वालिटी, कारण विंड ब्लेड ची क्वालिटी मात्र इम्प्रूव्ह करण्यासाठी आता नवीन स्टार्टअप केलेला आहे. बायो एनर्जी, ॲज वी ऑल नेट दॅट बायो एनर्जी कॅन बी युटिलाइज इन डिफरंट वेज, लाईक थर्मोकेमिकल प्रोसेस, बायोकेमिकल प्रोसेस, पायरोलिसिस, गॅसिफिकेशन. तुमच्याकडे टॉपिक असतील, तुमच्याकडे पायरोलिसिस आहे तुमच्या सिलेबसमध्ये, गॅसिफिकेशन, थर्मोकेमिकल. नो, कोणत्या वर्गात आहात तुम्ही? फर्स्ट इयर आहात का? फर्स्ट इयर बी. मला वाटतं तुम्हाला थर्ड इयरला असेल, थर्ड इयर किंवा फोर्थ इयरला. सो बेसिकली बायो एनर्जी, हाऊ वी कॅन रिअली यूज बायो एनर्जी, बायोमास, बायोकेमिकल मीन्स लाईक वी नो गोबर गॅस प्लांट, किंवा अशा प्रकारचे जे वेट बायोमास आहे, ओके, दॅट कॅन बी कन्वर्टेड इन टू methane. That is a biochemical. Thermochemical means if you heat wood, for example, dried biomass, if you heat it at temperatures 200, 300, 400 in controlled oxygen, then in fact you can convert it into producer gas like carbon monoxide, then hydrogen, then there are CO is there, I mean different gases, methane, ethane, propane, some of the gases, all it is called as a producer gas. And we can run engines with the help of IC engines, of course, and we can then go for turbines and you can convert it into electricity as well. The first gasifier was used in the Second World War by America. US ने Second World War मध्ये हा अशा प्रकारचा गॅसिफायर वापरला होता. Since there was a big clash in between the OPEC and non-OPEC countries, means oil producing and export countries, OPEC, like Saudi Arabia, Qatar, all these are OPEC countries, and non-OPEC means which are not producing or not exporting oil. Okay, there was a big clash in between this, and in the World War, the OPEC country decided that not to provide oil to non-OPEC countries. Since they are against us, they are enemies, why to provide oil to them? आणि त्यामुळं त्यांच्यामध्ये बरंच वाद झाल्यामुळं non-OPEC countries like America, they came forward, their scientists, researchers came forward, and they used this biomass as a source of energy, and they used it for running all these their vehicles. So that was the first big attempt how this biomass can be used for vehicles. That was the first attempt. So bioenergy is also very important. Bio oil is there, which is going to replace your other fuels. So bio methane is there, then many biodiesel is there. If you think of Brazil, for example, Brazil, they are using 40 to 50% of biodiesel for their vehicles. Ethanol they are using. In our country, ethanol is very hardly used, and therefore I think there is also big scope in going for this biodiesel and biofuels in for vehicles, transportation, and some other applications. Grid integration, as we know that there are different issues again in grid, and therefore we need to integrate these grids. Otherwise, whenever we go for photovoltaic solar cells, and when we get when we install this plant on our house or in building, then definitely there are issues, government issues are there. Like they will not accept immediately. Otherwise we are their clients. And if you use a solar energy, then definitely their clients are, reducing. And therefore immediately they will not take care. But that is one of the reasons that we should have grid integration, how to integrate all these grids. Whatever the sources we have, whether a solar, wind, and the normal hydel or coal, how it can be integrated. That is one of the issue. As on today, do you know that which source gives us electricity maximum? Yes? अंदाजे सांगता येईल? You said something, you? Thermal, म्हणजे कुठला source कुठला वापरतात? How much percentage approximately? Yes? 60 to 65% maximum. Okay? Hydel is around 25%, and remainings are renewable, nuclear, and all these sources. So green hydrogen, we had a talk yesterday, so I'll not take much time on this. It's a green hydrogen based fuel cell vehicles which are coming up. Then advanced robotics, that is going to play a very important role now in energy sector. Whether it is photovoltaics or photothermal or any sector, robotics is going to play a very important role, and therefore such a kind of startups are coming up. So whether you are from electrical side or computer side, it doesn't make a difference. Each and everyone can work in renewable energy sector. Rather energy sector. It is not only renewable, it is the energy sector. There are number of areas where you can work. Like you can increase the efficiency, you can conserve the energy. If you are able to save 1 unit, it means that you are generating 2 units. Keep in mind. So you may not generate, but if you save energy, that is more important than generating rather. Since whenever you get 1 unit over here, means it might have been produced 2 units over there from Koina or some thermal stations, NTPC, isn't it? More than 2. And here you are getting 1 unit. There are a number of other parameters, as you know. There are core losses are there, theft is there, akda, isn't it? It is there, no? So there are many other parameters. So around 50% loss is there. You are getting 1 unit, it means that you are generating 2 units. Drones are coming up now. Drones will play a very important role in renewable energy sector in coming years. Blockchain, like how we can really trade this energy, that is also very important. These are the 10 parameters where you can have different aspects or directions, how really you can go into this energy field and get the opportunities. These are some of the green initiatives. I will not go into the detail. These are just to give the information. So how solar energy can be used for purification of water. And it is coming up now. It's a new startup and it is coming into market now. Then photosynthesis, artificial photosynthesis is coming up. Photosynthesis right now, natural photosynthesis has a very less efficiency. But now artificial photosynthesis is coming up. And that is also will be a artificial plant with solar leaves. Now solar leaves will be there. जसं आपण घरामध्ये छान plants लावतो, isn't it? So you can have artificial plants and it will generate energy. It will look like a plant, natural plant, but it is going to generate energy. Tobacco plants also can use for solar cells. So also one of the innovation. Three-dimensional solar cell which I was talking about. More than 80-90% efficiency is possible with three-dimensional solar cells. Whatever the radiations are coming, all the radiations will be captured and it will be converted into electricity. This is the person who in fact did this work, nano Manhattan 3D solar cell based boost efficiency while reducing size, weight and complexity of photovoltaic arrays. So very high efficiency, more than 80% efficiency is possible with 3D solar cells. So these are some of the pictures which I just thought to share with you. World's first smog vacuum cleaner. Smog, it is going to clean a smog. So such a kind of building is there. So is the mastermind behind the world's first smog vacuum cleaner. The smog-free tower measures almost 23 feet height and sucks in polluted air, cleaning it through a process of ionization before releasing it again. At its peak performance, the tower cleans. So you can see 30,000 meter cube of air per hour. And even you can use this as rings. It converts into rings also. And you can wear it, these rings. Photovoltaic balloon, you can use it anywhere. You can take this balloon to any side and you can use the energy. So this is also a new kind of a startup. Jiffier is a photovoltaic balloon and eco-friendly, generated created by Karen Srab, Julie Dottel and Kedrick Thomisi, and their France-based startup. The autonomous aerial platform takes the form of a helium balloon. So this is also one of the very interesting thing. The green building initiatives, as you can see. Then robotics bees for pollination of crops. Some of the initiatives in green initiatives we can say. There is also Groesis water box was created by Dutch flower exporter Peter Hoff. Basically you can see that it requires very less amount of water. Air carbon was developed by New Light Technologies and has already won many awards for its innovative sustainability. It's made from carbon emissions that would otherwise be released into the air and can have a multitude of users. Solar glass could change the way of create homes and commercial buildings. Researchers at the University of Michigan are developing solar glass sustainable engineering project that has generated a lot of buzz in the recent years. So it is going to convert into electricity. Some of the pictures just to Sundrop Farms is known for cultivating a set of sustainable agriculture technologies that required fewer finite resources than the traditional farming. Now the solar farming is coming up now. In fact, couple of weeks before, our DCM, Deputy Chief Minister, has declared that how much amount will be given to the farmers for providing this one. Vegan bottle. The power energy is there, like as we know that the it is basically app. It is used, whatever the energy is required, accordingly it will give you the idea. Cloud fisher is there, it will be definitely used for 3D mesh, in fact it is, and can withstand high wind speeds while still retaining water. So it will convert this cloud into water and that water can be used. This is also interesting thing, like in spite of any kind of diesel, oil or electricity, this pump will work, and it can, with the flow of just water, you can, take water at higher, around 25 meters, 82 feet. It's called as the Barsha pump. Some of the very interesting projects. One of the project was in energy conservation. One of our student, in fact, she worked in a Thermax, and she found that, if you look at the last line, efforts have been made to save the energy around 4,35,000 kilowatt hour annually. That is, that time it was around 44.90 lakhs. And that student was taken by Thermax, and she was working in a R&D in Thermax. So if you do some project, if you concentrate on some project, definitely you will get opportunity in MNCs, big companies also. They really want, creative youngsters. So these are some of the projects which our students had done. Novel milking machine, hybrid vehicle, and so on. So this is now he's working in DRDO. He's a great scientist. I think a couple of months back he is awarded by our राष्ट्रपती. राष्ट्रपतींच्या हस्ते त्याला मोठा अवॉर्ड मिळाला. He is a big scientist now. So these are many projects. In fact, what is required is, whatever you are working, the area which you are working, you should see a relevance of this area, whether it is relevant as on today or not. It should be important for someone, maybe some area, some people, whatever it is. कोणाला तरी तो उपयोगाचा असला पाहिजे, कुठल्या तरी भागाला उपयोगाचा असला पाहिजे. Relevance is very important. Secondly, what kind of methodology you are using, that is equally important. कुठल्या मेथडने तुम्ही करता आहात, isn't it? Otherwise खूप अवघड मेथड घेऊन तुम्ही करत असाल तर it is of no use. Easily तुम्हाला कसं करता येईल ते आपण पाहायला पाहिजे. Thirdly, hard work. There is no alternative for hard work. You have to work very hard, in coming up. Otherwise, that is the basic difference in between European countries and our country. They are very focused, very focused. They will not waste their time. Okay, and they are continuously, working on some aspect. Fully concentration, full of concentration. I remember, I always say that since our Jagdish Chandra Bose, in fact, he worked in radio technology, but in fact, he invented that field. But unfortunately, he could not get a Nobel Prize. Nobel Prize went to Marconi. The reason was that he worked in only laboratory. Bose worked in a laboratory only, and that Marconi worked in a field 100 kilometers away. He showed that yes, whatever I am talking, you can listen over there. So it needs a focus. You need applications, you need a market, you should know market also. There are many things which are required. Innovation is required, something, out of box, not a same pattern, not a same thing. You will have to do something extra, something new, something innovative. And last and important is commercial viability, whether it is affordable to or not, common man or not. I think that is also equally important. So these are some of the slides which I just wanted to share with you. Thank you very much for your patience hearing. If you have any, you can clap, no problem. Thank you very much. Any questions? This is our problem. No questions. Either you understood fully or not at all. Yes? You all are from first year only? Yes? Huh? First year, mechanical, electrical, mixed? Mixed. Okay. There are many projects. I think that is what I wanted to know. Like, if you are interested in field, then I can talk on this line. Otherwise, I will ask you one question. How much is the efficiency of chula? चूल माहिती आहे तिची efficiency किती? Yes? Very good. Somebody said something. Who told? Yes? कोण म्हटलं सांगा. These are our problems, keep in mind. We do not know the efficiency of chula. We can talk about IT, we can talk about AI, machine learning, this and that. But we feel that these are not our problems, you know. Chul is not our problem. But still, around maybe 40-50% people, they are using chula as on today. If you go to rural area, around 60%, more than that, you know, people are living in rural area. This is our real India, real Bharat. So we do not know the problems of, you know, our real people. कि ते problems आपल्याला शोधायला लागतील. You have a tremendous scope in this field. Recently, one of my student worked on one very important problem. तुम्हाला माहिती आहे की ग्रामीण भागामध्ये आठवड्यामध्ये 2-3 दिवस तरी पॉवर असते नसते, रात्री बेरात्री येते, कधी निघून जाते कळत नाही. मग त्याने एक वेगळ्या प्रकारचा आम्ही एक डेव्हलप केला आहे की पॉवर तुम्हाला आली आणि आपल्या विहिरीमध्ये पाणी असेल की नाही हे दोन्ही गोष्टी त्याच्या प्रकारचे एक त्यांनी इंटरनेट बेस्ड वॉटर कंट्रोलर आम्ही तयार केला आहे. आणि तुम्ही जगाच्या पाठीवर कुठेही असला बरं का, जगाच्या पाठीवर कुठेही असला तरीसुद्धा तुम्हाला त्या विहिरीच्या पाण्याची लेवल किती आणि पॉवर आहे की नाही समजतं. अदरवाईज शेतकरी काय करतात अनफॉर्च्युनेटली की रात्री बेरात्री जर पॉवर आली तर ते चालू करायला जात नाहीत, कारण विंचूकाट्याची भीती असते. आणि समजा चालू केलंच तर बंद करायच्या भानगडीत पडत नाहीत. म्हणजे दोन्ही बाजूने, एका बाजूने चालू नाही केलं तर पीक जळणार आहे आणि जर चालू केलं तर पाणी वापरलं जाणार आहे. त्यामुळे अशा प्रकारचं केलं की तुम्ही कुठेही असून तुम्ही इंटरनेट बेस चालू करू शकता आणि तुम्ही त्याला टायमर पण लावू शकता. म्हणजे एखाद्या तासाचा 2 तास चालू ठेवायचे, आपोआप ते बंद होणार. आणि त्याला आम्ही पेटंट आमचं ते सँक्शन झालं आहे आणि अमेरिकन आमच्या एका कंपनीकडून त्याचं आता स्टार्टअपसाठी ते स्वतः त्याच्यात पैसे टाकतायत आणि ते आता एक स्टार्टअप नवीन सुरू होत आहे. त्यामुळे आत्ता जे भारतामध्ये चाललेलं आहे, आता थोडं स्टार्टअपला खूप चांगले दिवस आलेले आहेत. तर तुम्ही आता फर्स्ट इयरला आहात, आत्तापासूनच कुठल्या तरी टॉपिकमध्ये काम करायला लागा. कुठलाही टॉपिक घ्या, टॉपिक इज नॉट मच इम्पॉर्टंट. इम्पॉर्टन्स इज वेदर यू आर गोइंग टू कॉन्सन्ट्रेट इन दॅट टॉपिक ऑर नॉट. किती तुम्ही कष्ट घेणार आहात, दॅट इज मोर इम्पॉर्टंट. आणि बऱ्याच वेळा असं होतं की तुम्ही हे सगळं, बऱ्याच वेळा असं होतं की आपण थिअरॉटिकली बरंचसं शिकतो, प्रॅक्टिकली आपल्याला फार अप्रोच राहत नाही आणि त्यामुळं मग आपल्याला जॉब्स मिळत नाहीत किंवा जॉब मिळाले तरी चांगल्या प्रकारचे आपल्या अपेक्षेसारखे आपल्याला मिळत नाहीत. त्यामुळं कुठल्या तरी प्रोजेक्टमध्ये आत्तापासून काम करायला लागा, इंडस्ट्रीबरोबर काम करायला लागा. कारण आता रांजणगाव MIDCबरोबर आम्ही कोलॅबरेशन केलं आहे आणि दे रिअली वॉन्ट अ स्किल मॅन पॉवर, दे रिअली वॉन्ट अ स्टुडंट्स. तर ते मला वाटतं अशा प्रकारचे स्टुडंट्स त्यांना गरज आहे आणि कुठेतरी तुम्हाला त्या दिशेनं तुम्ही जर गेलात तर मला वाटतं खूप चांगलं भवितव्य तुम्हाला असू शकेल. मला वाटतं मी थांबतो, बराच वेळ झालेला आहे. थँक्यू व्हेरी मच फॉर युअर पेशन्स.
Students, any questions? Third year NTC students. Okay. So thank you very much, sir, for your precious time and the knowledge you have shared with our students and participants for our green energy international conference on green energy. Definitely, sir, means whatever the suggestions as well as the research area you have discussed with students, student will take a benefit of that. So thank you very much, sir, and hopefully, sir, means we will again guide our students in coming future whenever we'll call you. Thank you very much, and I again thank our AISMS management for giving us this opportunity to conduct this international conference on green energy, and all the participants and the students from AISMS College of Engineering and the participants, those who are just join this keynote session in online mode on YouTube as well as Teams. Thank you very much all, and this is our last day. So, miss, by 4 p.m. miss will end up with this international conference. So, thank you all. And after this, participants, miss, you should wait for the lunch. Thank you. And first year and other students can go to your respective classes. Thank you.